Cults, welcome to Readiness Assessment 6, Part 1. Question 1, we got to determine if it's greater than, less than, or equal to. So if you remember, when we have negatives, it's like this 3 to the negative 2 is on top. In order to make it positive, we're going to move it downstairs. So I have a 3 to the third on top over a 3 to the second. And if I were to rewrite that, that means I have 3 3s on top and 2 3s on bottom. So these cancel out, and I'd end up with just 3. Looking at our second one, I'm going to have a 3 to the negative 3 on bottom this time. So I have 3 to the second on top, and then that negative 3 is going to move to the bottom. So I end up with 2 3s on top and 3 3s on bottom. These cancel out, and I end up with 1 over 3. And so we see that 3 is larger than 1 over 3, or greater than. So we're going to do our inequality facing this direction. Number 2, we're going to take x squared y cubed over xy, and we're going to see which ones are equivalent, and it says select all that apply, which means we're going to have more than one solution. So we have 2 x's on top, 3 y's, an x, and a y. So if I were to take these, I would cancel out one set of x's and one set of y's, which means I'd be left with x, y squared. So if I look at A, let's see that that one matches it. But because it's select all that apply, we're going to go through and see if there are any other ones. Well, right now, I know that I'm not going to have 3 x's and 4 y's, so I know it's not going to be D. But if I look at B, I have x with 3 y's and a y on bottom. I could cancel out a set of those y's, and I'd have 1 x and 2 y's, just like our original solution. So that one works. And then if I look at C, one of our x's is going to cancel with this x, so I'm going to end up with x, y squared, which is also the same. So C is also equivalent. All right, if I look at number 3, a to the third raised to the 6th power means I have 6 of these. Now, we don't have to go through and write them all out, but instead, if you remember, we learned a property called power of a power, where we take those and we're going to multiply them. So 3 times 6 is going to give us 18. And then question 4 asks us which property, so we just talked about that in number 3. We know it's not quotient, it's not division. Product means that I have something that's multiplied. That's if I have like x squared times x to the 5th. There's a product. And in this case, there's only one base. And because it's a power and another power, we're going to call this one power of a power. Number 5. This is going to be a square root, which means there's a 2 there technically. So anytime we don't see a number, there's a 2. That means we're looking for groups of 2. They don't have to necessarily be the number 2, but we're looking for pairs. Now in this case, this tells us that we have 4 2's. So we're going to circle the pairs, and we see that we have 2 pairs. So a 2 comes out from this one, another 2 comes out, and we do 2 times 2, which gives us 4. For number 6, this is a cubed root, which means we're looking for groups of 3. So if you take your 27, you can break it down. It's 9 times 3, and then 9 is 3 times 3. I like to cross them off as we go through and simplify them so we don't include them when we do our circles. I'm looking for groups of 3. And also in this case, it does not necessarily have to be the number 3. I'm just looking for 3 of the same thing. This one just happens to be 3. So my solution for this one is going to be 3. Okay, for number 7, you might need a calculator because you might not be able to do it right off the top of your head, as we're talking about percents. But this one's talking about how much are they increasing by. So if you think, if I go from 50 to 75, well, that means it goes up by 25. Well, 25 is actually half of what 50 is, right? So it's 50% of what 50 is. But we go through and we might see when we have 700 and 500, it might get a little bit confusing. So the best way to do it is I'm going to do that 75 and I'm going to divide it by 50. And when I do that, I'm going to see how much bigger is it than the number 1. So when I do that, I end up with 1.5. So 1 would just be 100%. So if it's 1.5, that technically stands for 150%. So in this case, it increased by 50%. And so we want to see which one has the greatest percent increase. So then I'm going to do 700 divided by 500. And that's going to give me 1.4, which means it's a 40% increase. So we already know that that one's less. If I do 7,000 divided by 5,000, okay, think of it this way. We could go through and simplify them, cross off our zeros, and it would be the same as our 700 and our 500 one that we did before. So we end up with 1.4 again. So again, it's a 40% increase. And then if we did 74,000 divided by 50,000, we would get 1.48. And in that case, we would say, okay, we have a 48% increase. So A trumps them all, the 50%. Okay, moving on to number 8. Number 8, this one we're going to see how it decreased. So it's going to be a little different, but we're going to do the same type of thing. So we're going to do 2,000 divided by 100. And you could say, all right, if I do 2,000 divided by 100, that gives me 20. And we're like, how does that help us? So maybe let's go the other way because we're doing decrease this time. So let's do, instead of that, let's do 100 divided by 2,000. When you do 100 divided by 2,000, you end up with 0.05. So in a way, it's like telling us that's what's left. So in order for me to get to 100, I would need 95 more percent. So technically, when I went from that 2,000 to that 100, I only have 5% left, which means that I decreased by 95%. Number 9 says which statement about the data and the table shown is true. So if I go from -2 to 1, I add 1, I add 1, I add 1. And if I go from -3, so that one, so for my x's, I see that it's 1. So if I see how much the y's change, that's going to give me my slope, or tell me how they change, if it's consistent, if it's inconsistent, and it tells me what type of function. So if I go from -3 to -1, I know I'm going up, and I'm going up specifically by 2. If I add 2, does it work for this one? It does. And if I do 1 plus 2, I also get 3. So in this case, we see that they are the same every single time. So yes, it's a function, so it's not going to be that one. Is it a nonlinear function, a quadratic function, or a linear function? Well, if it was quadratic, it would increase more. We haven't really talked a whole lot about those. But linear function is going to be the one we're going to go with because we have a constant slope, or a constant rate of change of 2. Okay, we're going to move on to number 10. So for this one, we're going to write it in y equals mx plus b. We're going to write that function. So if you remember, starting off, when I have this 0 to -2, that's going to give me my value of b. So I need a -2. So this one has a -2, this one has a -2. So I can eliminate 2 of them already. And now, my option for A has a 3. I'm going to have a -3. So am I going up or am I going down? Now, you got to notice though, if I go from 0 to 2, that's adding 2. It's adding 2. And then I'm adding 1. So if I go from -2 to 4, it adds 6. But that's twice as many spaces. We need to remember. If I go from 4 to 10, that's also 6. But this one right here is awesome because it only goes up by 1. So that's going to give us our true slope. If I go from 10 to 13, it's only adding 3. Now, part of it we could have said, okay, well, it's going up, so I know it's going to be the positive one. But that's where I get that 3x, because it increases by 3. You got to make sure you check your x values. Okay, and then the last one, number 11. It says which function is represented by the graph. So this one's a little different because we got decimals. So first thing we're going to start with is our b. What's our b value? Well, it's here at -2, but if you notice, all of them are at -2, so that doesn't help us. But if we look at our slope, is it a positive slope? Is it a negative slope? Is it a horizontal slope? Or is it a vertical slope? Horizontal means it would be flat going this way, so it's not going to be that one. Vertical would mean it'd be straight up and down. It's not that one. And negative would mean we're going on a decline or down a hill. And it's not that one. So we're going to end up with a positive slope. So right now we could say, okay, it could possibly be this one, This one, not B, and not D, because those are negative. And now you need to just find a good point. Well, we have our first one, our y-intercept, and if you look, these guys don't really cross nicely until we get all the way up here. And so we say, okay, how much am I going to rise? 1, 2, 3, 4, 5. So I'm going to go up 5, and then I'm going to run 1, 2. So you say, all right, I have 5 halves. Is that going to be 0.4, or is that going to be 2.5? And if you're not sure, put it in your calculator. But we end up with 2.5. We should also know that it's bigger than 1, so it's not going to be A. And so we end up with C. And that concludes part 1 of Readiness Assessment 1. Or excuse me, Readiness Assessment 6.